Okay. Hi everyone, and thank you for joining today's webinar. Today we'll be discussing how we can use LOCTITE solutions to repair, rebuild and reclaim industrial pumps. So, before we start, I'll just give you a brief introduction of myself. So, for anyone that doesn't know me and or anyone that's joining from overseas, my name is Mark Casotti. I've been with Henkel for almost 10 years now. I was originally an automotive technician and then moved on to agricultural machinery and some small earth moving equipment. So that's really my background in my mechanical background. But since pursuing a career in technical sales, I spent 13 years in industrial sales, specialising mostly in fluid transfer systems, and then moved on to adhesive solutions. I've worked extensively throughout WA, including areas like the Southwest, the Goldfields region and the Pilbara region. Okay. Let's move on. So most industrial pumps carry significant capital equipment value. Therefore, it's important to extend their useful lives and ensure they run efficiently and reliably. On top of this, they're capital equipment with a really high replacement cost. Proper installation and proper maintenance allow pumps to run efficiently and are pretty high priorities for most manufacturers. Pumps are a critical component of any manufacturing operation. When pumps aren't running efficiently, the plant's not running efficiently. If maintenance is seen as expensive, then the cost of failure or a breakdown is definitely higher. Also, improving the efficiency of a pump can translate into substantial energy and other cost savings. Most pumps are subject to a variety of constant external forces such as high pressure, vibration, abrasion and erosion. Plus, they're often installed in areas where they're exposed to some pretty extreme conditions of high and low temperatures and also some corrosive elements. They can suffer from maintenance neglect. I'm sure all of you out there have seen pumps that have just been left and the only time they're touched is when they stop working. All of these factors can contribute to the shaft of a pump becoming misaligned with the motor, fluid leaks and some pretty severe wear of internal components. Wear, corrosion, misalignment and leaks generally are the most common pump failure causes. In this webinar, we'll address all these issues and provide the best LOCTITE solutions for a pump repair and rebuild. There are a lot of applications we could talk about on pump repair and rebuild. Today, I'm only going to cover some of the most common ones. So what we'll cover is bearing retaining, gasketing and sealing, thread sealing, and also some repair of corroded and worn surfaces. Okay, so the first problem we're going to address today is wear. Now this can be caused by a number of factors, but we'll get into that as we move on. Okay, so a lot of industrial pumps are subject to internal wear and erosion from slurries or cavitation. Parts such as the pump casing, wear plate, the throat plate, and the impeller are all common components that will experience wear. A worn impeller or volute will always result in a decrease in pump efficiency. Pumps are also subject to environmental attacks through corrosion. Corrosion can be caused from normal rust or oxidation, but it's also often the result of more heavy chemical attacks. Pump casings and impellers are critical and expensive elements of the pump. Damage to these parts generally result in the pump being replaced once it's operating outside of its BEP or best efficiency point. All wear really can lead to pump failure. Higher maintenance costs are also part of that for either repair or for replacement. So our range of LOCTITE protective coatings help to ensure your valuable pump assets are protected and that your pumps are always operating efficiently. So our solution is our range of wear-resistant coatings. These are designed to protect pump parts from premature wear. So our protective coatings are a special type of composite. They're generally a high-grade epoxy base reinforced with different fillers that are designed to resist specific forces such as slurry abrasion, impact abrasion, chemical attack, and others. These products don't only restore worn parts, but continue to protect your parts by providing a sacrificial wear surface that can easily be replaced without needing to replace the parts themselves. So now we'll play a two-part video that shows how we would do a typical repair on a small pump impeller and on a wear plate. I'd also like to take this chance to thank Pump Solutions Australasia, who's one of our preferred LOCTITE applicators, for allowing us to use their excellent workshop facilities. But let's get into the video.
Okay, so first of all, we're going to do the first part of this, which is starting to rebuild this wear plate that you can see here, and also this impeller. What you can see on the wear plate is quite a bit of wear. It's probably between 3 to 5 millimeters deep. We're going to bring this surface back to being completely flat, because this pump at the moment, on its last flow test, was running at about 40% of its original efficiency. As for the impeller, you can see it's quite pitted. Now, some of the minor pitting we're not going to worry about for this pump because it's not a very extreme service pump, but what we do have is quite a bit of wear here along the edges of the impeller. So we're going to repair that, rebuild that. We're going to let this sit for a little while after this, and then we're going to do a final coat over the top to give it a nice smooth finish. So, first of all, with any type of repair work or any type of coating work, the most important part of it is to make sure the surface is prepared well and it's cleaned. So prior to being grip blasted, these were cleaned using LOCTITE SF7840. Then they were grip blasted. After that, we blow them down with nice, clean, dry air. And then finally, we will give them a quick wash down with a solvent. So we're either going to use VR10 or SF7063, both of these products can be used as a solvent cleaner. Then we'll move on to mixing on the product and applying it. So first thing I need to do is the area we're going to be coating, give it a quick clean. And you'll see this is quite a fast flashing solvent, but I will just grab a cloth to speed it up. So you can see how fast the solvent comes off the surface. And that's taken all the additional contaminants with it, any oils that are going to stop our adhesive or our epoxy from bonding. Okay, so to do this, with this one, because this is a wear plate, we're going to use a product called LOCTITE PC7222. It's a two-part epoxy, and it's a ceramic-filled paste. So, the product's a 2-to-1 mix, so I'll get out twice the amount of the part A. It's quite a thick and heavy product, so this one does take a fair bit of mixing. Use half the volume. All right, so main issue here is to make sure you've got an even mix of the product. So you basically need to fold two parts together consistently until you get an even colour. So you can see at the bottom here, we still haven't got an even mix. So this can take up to a couple of minutes to make sure you've mixed it correctly. Okay, so I've been mixing this for about a minute or so, and it looks to me like we've got a fairly good mix at this point. There's no unusual colouring through it. It's all an even sort of dark grey colour. And for now, we're ready to apply it onto our surface. And what we're going to do is just build this surface, as I said, back to its original level, and that's going to allow for complete efficiency of the pump. So we'll be able to get our clearances between this and the impeller correct again. So the best way to do it is to just put a small amount across the surface to begin with. Always looks messy from the beginning. And depending on the application of the pump, what the pump's actually being used for, it's quite important to really select the right product. In this case, this pump, it doesn't experience a huge amount of wear. So this is quite a fine product, but it's still very wear resistant. If the wear is more significant, say it's pumping a large particle slurry, then we'd move on to one of our heavier duty epoxies like PC7226. But for this application, this will do the job. All right, so now that we've got a nice coating on the surface, or enough product onto the surface, what we're going to do is basically just work this in. One of the things you don't want to do is work the product too much. You basically want to get a nice even coat and try and keep it as level as possible. And you can work with this for about 10 to 15 minutes, depending on the ambient temperature. So what we'll do now is we'll allow this to cure for a little while, and then basically we can come back and just, as the product's starting to harden, we can just take off the edges and we can get it completely flat, ready for the next coat, which will be a spray-on ceramic coating that we're going to brush on in this application because it's so small. All right, now that we've finished the wear plate, we're going to move on to the impeller. So what you can see here on this impeller is there's quite a bit of wear along the leading edges, which basically is what's cutting through the water. This is going to start to cause a fair bit of cavitation, and also there's a little bit of pitting all over the impeller itself. So we're going to use the same product we were using earlier, which is the PC7222, the wear-resistant putty. Again, I've only just mixed this, so I can still continue to use this for about the next 20 or so minutes. So what we'll do, again, it's only just a small part on the edge, but we're going to fill in all the way along these edges and on this side as well. And if I do notice as I'm going any other large damage, so areas where it's pitted a little bit more, that's what I'll fix. Getting just a small bit of the product, and with pitting in areas like this, you really do need to make sure that you work the product right into the surface and that you don't have any holes or any air bubbles trapped underneath that could potentially allow the product to lift off later. Now, one of the questions a lot of people will ask when using these products is it going to cause any balance issues with the impeller? In a lot of cases, it won't for this type of repair. If you're doing some real major repairs, like repairing a huge piece of metal that's been removed, then in those situations, yes, it can affect the balance, and it would always be advisable to check the balance of the impeller afterwards. So, one thing you will see is some of these areas where the pitting's quite deep, what you will need to do is make sure you apply the product from different angles to ensure that it pushes product right into the pitted areas, and then we get a good bond to the surface right at the bottom. Okay, what we're going to do at this point is we're just going to leave this for a little bit longer, and we're going to allow the product to start to cure just that little bit. So probably in this temperature, I'd say we'll leave it at around another 15 to 20 minutes. Then we'll come back and we'll finish this off nice and neatly. Then we'll move on to the next step. So now that our wear plate and our impeller have both had a bit of time to cure, we've repaired all the damaged edges, we've repaired the face of the wear plate. We're now going to apply a ceramic coating, or an epoxy-based ceramic coating, to the whole outside. So the product we've chosen for this one today is LOCTITE PC7255. This is a sprayable ceramic coating, as you can see by the gun that we're using. Now, because of the size of this application, we're not going to spray the product, but we're going to show the other advantage of this product is that it's quite versatile. It can be used to spray, or it can be used as a brush-on product. The advantage of using this one as a brush-on product is it's self-mixing. You don't have to worry about mix ratios when you're working with the two products. So what I'll do is I'm going to dispense some of the product into a small bucket or a container, and basically then just brush it over the two surfaces. Now, one thing you need to note with this is once these are cured, or the point that when you should apply your second coat is once these are cured to the point where you can basically touch the surface of the product, and it's still soft enough that it'll just leave a fingerprint, but you don't really indent into the surface of the product. So it's hard enough that you can't actually change the shape of the product. And one of the things to do with these guns, or with these cartridges more to the point, is to make sure that the cartridge is flowing properly. So take out the two covers And then the first thing we want to do is connect up to air. And I'll just need a cloth, which I will put here. And all you want to do really first is just pull the trigger slightly and make sure that you've got both colours flowing from the cartridge. Let's just make sure there's no air bubbles and there's no blockages in the cartridge. Then you fit your nozzle, your mixing nozzle. Now, if we were to be spraying this product, the next thing we would do is we would connect up this hose. This will atomise the product on the way out of the nozzle. But because we're just going to use it to mix the product today, I'm going to leave this off and I'm going to apply it. I'm going to mix it straight into the bucket. Okay, so what I'm going to do is just dispense the product straight into this bucket, which will allow it to mix itself up, and then we don't need to worry about it from there on. We can just apply straight onto the surface of the impeller. Now, the best way to apply this product when you're using a brush is to make sure that you've got a shorter brush than normal. So you want quite short bristles, and that's there really, the reason we use that is to force the product into any of the small pitted areas that we haven't filled up completely. So first thing you need to do is just make sure your product is completely mixed. So you just want to make sure, just give it a quick mix around with the brush to make sure it's all completely mixed. Just because when it first does come out of the nozzle, it doesn't always come out evenly, but once it starts to flow, then you get a nice even mix. All right, so then we basically start to apply our first layer of the coating. And again, it's the same as any coating. You really want to move back and forward in both directions and make sure you're moving your brush in different directions, just to ensure that you're filling up any holes in the surface and you're getting a nice even coat. So this product is quite thin. It will run a little bit, but you do have a fair bit of time to work with it, so you can move it around. Don't worry too much if you don't get a completely even coating on your first coat, because we will be doing a second. And the second coat is really there just to make sure we get enough surface thickness to give it its abrasion resistance properties, and also to make sure that we've got a completely sealed surface so we don't get any water making its way through and causing an issue with delamination of the coating. But you can see the coating flows quite well, and as it's quite a thin coating, what it will do is basically self-level, and we'll end up with a nice, smooth, even finish. One of the other added advantages of this is it does provide a very low friction surface. Won't be a huge issue on this pump, but on a lot of larger pumps, it does reduce, it can reduce the actual power consumption required to run the pump. As you can see on the inside, it's already starting to level itself off a little bit. Just through this area in here. If you do start to see any areas where it's running, just a quick skim with the brush tells you you've got the product on just that bit too thick, and that'll catch it before it gets any worse. Okay, so that's it for now. We've basically got the coating completed on both parts. So hopefully from the whole video that everyone's been able to learn something new or seen a couple of new applications for the LOCTITE products and where they can use them to help in their everyday work that they're doing. Our main aim here is to increase the reliability of any of the parts we assemble, or increase the lifespan of whatever we're assembling as well. So if we can get this pump back up to 100% efficiency, that's our aim, or even slightly above now that we've got a nice low friction coating. Finally, the last thing I'd like to do is just thank Adam and the other guys at Pump Solutions Australasia for having us here today and giving us their workshop. And really, that is it. So thanks very much for watching.
All right, now that you've seen some repair methods for the pump case and the impeller, we'll move on and we'll tackle some of the problems associated with misalignment and leaks. Now, Most pump companies and most maintenance operations will invest time and education to develop skills to conduct proper shaft alignment. This is to ensure that the bearings and the critical components of the pump last beyond their expected life. However, if pump base mounting bolts lose their clamp load because of vibration, thermal cycling, impact or shock, then it's highly likely that despite the best installation practices, you'll still experience premature bearing failure and wear on the internal pump components. So all threaded fasteners have some degree of gap between the threads, even when under tension. This air gap is necessary for assembly and disassembly. However, forces like vibration and even constant changes in temperature can cause movement, and basically they'll result in a loss of friction between the threads, which then result in a loosening of the fastener. So typical assembly methods rely on ineffective locking devices such as split washers or split ring lock washers. Split washer is simply not effective on hardened steel components. In most cases, to loosen a fastener that's fitted with a split washer, it only requires about 80% of the torque load originally applied to tension the fastener. One of our most common thread locking solutions is LOCTITE 243. LOCTITE 243 thread locker, being a liquid in its uncured state, fills the airspace that exists in all nut and bolts assemblies. By filling this airspace, you seal the threads and eliminate the possibility for corrosion and seizure of the assembly. Once cured, the locking benefits of 243 prevent the fastener from loosening prematurely. This helps to ensure that proper alignment is always maintained. LOCTITE 243 also cures into a hard thermoset plastic, which provides 100% seal to prevent further fastener corrosion. LOCTITE 243 is a removable strength thread locker, which means that you'll be able to disassemble the nuts and bolts with the same tools that you assembled them with. Removal will be predictable, it'll be the same time every time. Without a thread locker, you're much more likely to experience seized nuts and bolts, or loose nuts and bolts. You never really know. Using 243, you can be confident that the assemblies that you've put together will stay together until you're ready to take them apart. So leaks are probably the most common challenge for pumps. Leaks generally occur from threaded fittings or from flanges. Again, this air gap or airspace is the primary culprit. LOCTITE thread sealants seal the airspace within a threaded fitting and secure the fitting in place to ensure that it doesn't loosen from vibration. Our thread sealants don't contaminate any of the lubricating oils. They will stay in suspension in the oil. Our flange sealants ensure that the air gaps within a flange assembly are filled as well. Generally, a flange is two flat faces. The product will always fill up any of those air gaps in between and give you 100% seal. So using the two in combination, the flange sealant and a thread locker, pretty much ensures that you're going to have a leak-free assembly. So let's take a closer look at sealing threaded assemblies. PTFE thread tape creates leak paths and other problems that affect the final seal, and they can also contaminate other areas of the system. When the thread tape breaks apart, it can end up moving its way through the system and blocking other parts. So the other thing we'll look at is how using a liquid thread sealant eliminates all those issues. Next up, we'll show you a short animation that describes the differences in a little bit more detail. now we'll move on and we'll show you a short video of how we generally apply a thread sealant on some threaded fittings. The fittings that we're using make up a manifold assembly.
We're going to move on and show you how to use some of our anaerobic thread sealants to seal up a manifold. Now this is quite a typical type of manifold that you'd see coming off the top of one of these pumps. The guys here at Pump Solutions have shown me exactly what they want assembled. Now in this situation, this manifold's under a bit of vibration and a bit of pressure, so we're going to use LOCTITE 577 and we're going to use LOCTITE SF7063 to clean them all prior. Now if this was something that was going to take us a long time to assemble and wasn't going to be under severe pressure like this is going to be, we'd use LOCTITE 567 because that'll give us a lot more working time. 577 is a bit faster when it cures, but the added value it gives is it actually locks the fittings in place. All right, so as this is all these parts that you can see here, they're all stainless steel. This is all laid out the way we need it to be, but the most important thing to do here first is to make sure all our fittings are clean. So what I'll start with is basically just disassemble one of the fittings. We'll just work our way through it rather than just disassemble the whole thing, because then we're going to get ourselves lost. So first step is to use LOCTITE SF7063 to clean it. Now this is a solvent-based cleaner, so it's very fast to use. It doesn't take a lot of time, but you do need to ensure that the surface is dry before you apply the product. Okay, so we're using LOCTITE 577. Now this has got quite a wide tip on it, which this tip is designed to allow you to apply the product into all of the threads. Just a nice even bead. You can basically use the tip to push it into the threads a bit. That's our first fitting. Now really, as long as you can see product being expelled from the edge of the fitting, you know you've got a good seal. This being a liquid thread locker, and like any liquid, what it'll do is it fills up all of the gaps, any air gap in between the threads, and gives you a 100% seal. Now, in comparison to something like thread tape, you can see that's a fitting that's had gas-rated thread tape applied, and then the fitting's been screwed on and removed again. It actually hasn't filled up any of the gaps between the threads. All it's done is push all the thread tape back to one end and is absolutely useless at this point. So I'll move on to the next fitting. And again, wind our two parts together. With 577, as I said, we do need to be quite fast and we need to make sure we've got the fittings where we need them. You've got about, on stainless steel, you've probably got about 10 minutes of working time to work with it. After that, if you do need to move any of the fittings, you need to remove them and clean them and start again. All right, and from that point, that's it for now. We'll assemble the rest of this and then we'll show it to you again when it's all assembled. All right, so at this point, we've now assembled the complete manifold. All the parts are together. Everything's been tensioned up. It's all in place. It's exactly the way we need it. That's basically a lot of fittings and a lot of points where it could come undone. This will lock all of these fittings together. So at this point, this has been together for a little while now and I already can't move any of these fittings. They're already all tight in place. So that's it.
Okay, so that's the threaded fittings taken care of. Now let's take a look at flange sealing. The next animation explains how pre-cut gaskets create leak paths and some other problems that can affect the integrity of the seal. Then it compares how using LOCTITE anaerobic gasketing solutions can eliminate those problems and get you much, much closer to a completely leak-free system. So apart from what we've already seen, there are a lot of other ways we can help you maintain your pumps and equipment. So things like corrosion, keyway wallow, damage to the shaft, surfaces, they're all just examples of typical problems. The good part of this is that we've got solutions for pretty much all of these issues. In the next video, you'll see an example of a LOCTITE retaining compound and also the application of an anaerobic flange sealant on an electric motor. So other than the pump itself, we're talking about the periphery now. We'll install the bearings onto the motor shaft, and we will also seal up the covers to prevent water and dust ingress.
Okay, so one of the other applications that's quite common when assembling a pump is we need to look at the motor itself, what's driving the pump. So we've just installed 2 new bearings onto this shaft already, but what I'm going to show you next is basically how we're going to use one of our thread lockers, one of our retaining compounds, and our flange sealing products to actually assemble the 2 parts. So, in this case, for this motor, this has been rebuilt. This is new bearings, but when measuring the actual outer housing, these ones are right at the end of their maximum specification. So we want to make sure that this bearing here is not going to spin in the housing and it's going to operate as it needs to. So what we're going to do is we're going to use LOCTITE 680 to lock this bearing in place. And then once the bearings have all been assembled, then we'll put both rear flange plates on and we'll show you how that's all done. And then finally, we'll apply LOCTITE 243 to the bolts to make sure they don't rattle. So we'll get started. We'll give everything just a quick clean. So I'll do that here. So you can see that was still quite dirty inside. And as I said earlier, you do really want to make sure that the surfaces that you're bonding to are as clean as possible. The cleaner the better the surface preparation, the better the final result. So all we really need to do here is make sure that the bearing and the housing are both clean. And then when using a retaining compound, really you want to make sure that you're just going to get your product coverage complete. So what you need to do is apply a small amount of the product on the inside here of the bearing housing and also a little bit on the leading edge of the bearing as you're pushing it together. Put a small line of product around the inside. Now you don't need to worry about a little bit of excess product being squeezed out. That will stay liquid and can just be wiped off later. And then a small amount here on the leading edge of the bearing. So that's the first bearing assembly ready to go. Push them together, find our alignment marks, check the housing all fits. Okay, that is all looking good. Now I'll just keep that separate for now, so we still need to be able to apply the flange sealant and give ourselves a little bit of space. Right, what I will do is I'm going to use the new LOCTITE 518 pen just to seal these 2 edges here, just to make sure we don't get any water ingress into there. So the first thing I'll do is press on the pen, on the back of the pen a couple of times to make sure we've got product flowing. As you can see it there, just coming out past over the end of the roller. All we need is a very, very small amount, because this area is not that big. I'm going to apply it to both surfaces. That's it. Great thing with the pen is there's no mess, there's no product wastage, and we can make sure that's completely assembled. We've got those 2 pressed up against each other. That's ready to go. Our marks are lined up, and I'll move as quickly as I can straight onto the next bearing. What I might do in this case, so you can actually see the application a little bit better, is I'll apply the flange sealant first on here. There we go. Small amount on the back of the motor. Okay, and again, same process as the front bearing. is just a small amount here. Here we have to be a little bit careful of the thrust washer sitting in there. Try not to get too much or any product on that if we can. Same on the rear bearing. And as quick as that, we can assemble the two parts. Give it a small tap and we're done. I'll quickly put the bolts through. When applying a thread locker, you don't need to use a huge amount of the product. Basically, all you need to do is put it where the nut is going to actually sit once it's tensioned up. Bolt through. I'll just repeat this process for the next 4 bolts and then we'll be finished. Okay, so that's it. That's our motor assembled. Everything's been done. So you can see basically we've covered 3 different product applications or 3 different product types. We've used LOCTITE 518 for our flange sealing application. We've used LOCTITE 680 to assemble the bearings and lock the bearings in place to ensure we don't get any additional excess vibration or any bearing movement. And then finally, we've used LOCTITE 243 thread locker to make sure that the mounting bolts, so the flange mounting bolts, don't rattle loose at any point while the motor's running. The other product that was used was the SF7063 cleaner. That's used to make sure that any of the parts we're assembling have no contamination, no dirt, no oil, no grease. That's it. That's our motor assembled. On to the next part.
So that's it for the applications we'll be covering today. I hope you've been able to learn something from what you've seen. But if you want to learn more, let's talk about how else we can help you maintain your pump assets. LOCTITE have a range of training workshops, all designed to increase equipment reliability and reduce overall operating costs of equipment. The most relevant to what we've just seen is the pump repair workshop, which is an offshoot of our popular surface engineering workshop. The content of the workshop is focused on solutions that address each of the 4 points that you can see on the screen. Ultimately, maintaining and repairing pumping equipment using the most suitable solution will result in an improvement in safety and overall reduction in operating costs. So, what makes LOCTITE a world-leading solution provider? Really, it always boils down to these 3 key points. Our team of technical engineers work closely with you and your team to understand the day-to-day challenges that cause unplanned stoppages and ultimately unplanned risks and costs. All of our team members generally have a trade or engineering background, so they've been there and they've seen the chaos that's caused when critical equipment fails. We all undergo extensive training to better understand each of the industries that we're working in. Finally, Henkel's one of the world leaders in adhesive technologies. We consistently invest in R&D to bring the newest and most innovative technologies into our MRO markets. So how does the process work? First of all, it starts off with a plant survey, so we can really understand your current situation and your needs, so that we can then fine-tune our solutions. We also help you then with really specific solutions for your assets. After we plan out the details and all the logistics for the training, we then work with your maintenance team to teach and practice proven solutions so we can increase reliability at the base component level. After the workshop, we're then able to assist with specific application needs and challenges. We can report on the information that we've gathered as we've gone, and that's information that you can then use. So if you're looking to have one of these workshops run at your site, what are the next steps? Really, first of all, either contact your local sales engineer. You can also get to us through our tech hotline. Give us an overview of your plant and maintenance issues, and then based on that, we'll either schedule a maintenance reliability workshop, an MRW, or a surface engineering workshop, which is our SEW. The differences between the two, the maintenance reliability workshop really focuses on our traditional range of LOCTITE products. So our anaerobic thread sealants, gasketing, retaining products, and our thread lockers. Whereas the surface engineering workshop generally looks at our surface rebuild epoxy products. So our wear compounds, our ceramic coatings, which you've seen in the videos earlier. The other way you can get into contact with us is you can use the survey form that you'll see at the bottom of the screen. and either leave us some feedback there or send us your details and we'll contact you. All right, so that's the end of the presentation for today. I'd really like to thank you all for joining. But for the next few minutes, we'll open up the line to answer any questions that you've got about what you've seen today. Hopefully there's a few sitting there in the Q&A.
Mark, thanks for that. Really insightful, and really enjoyed actually seeing the practical applications. So well done.
Logged on already. We'll be starting
in action. Right, Mark, are you there?
Yes, I am. Thanks, Brendan.
Thanks for that. If you didn't catch that before, was great to see, and the actual practical application of applying the product was very useful for a lot of people attending, I'm sure. We had a question pop up while you were presenting, and again, I'd encourage anyone that's online at the moment, if you have any questions, please just populate the Q&A, which can be found at the bottom of your screen. There's a little button down there, so feel free to pop any questions in. We don't have too much longer, but if any other questions come up, I'll certainly address those to Mark. So one of those questions was, you're an expert at this by the looks of things, but practically, who can apply these products, and how easy is it to train somebody up?
So there's a couple of different ways to do it. I mean, these can be applied by the end user, the asset owner. We can support that by going out and running. Let's say we start off with an SEW demonstration, and from there we'll train up specific people in their workshop to do it. The other option, if they don't want to take on that role themselves, is we have a team of applicators around the country. All you need to do is contact us from that point, and we'll put you in touch with the applicator that's going to be able to do the job for you.
Fantastic. We've had another question come in from Jag Surrey, so thank you, Jag, for your question. They ask, how do these products compare with hard facing, wherever applicable, as an alternative to ceramic coating?
So it all depends. That's a tough question to answer, because it all really depends on the operating conditions of the pump. In issues where you've got quite severe impact, or in systems where you've got severe impact or really high velocity, sometimes these products can be a little bit more beneficial because they can be repaired easily. They will wear at similar rates to most hard facing, but in some cases, the biggest advantage is the fact that you don't need to remove the complete coating to be able to repair it again. So you can patch over the top of itself. Right.
Another question just come through from Thomas, and I'm not going to try and pronounce Thomas' surname. So Thomas, thank you for your question. Thomas asks, is there any special personal protective equipment that you need to use while applying these products? You obviously had gloves on, but is there anything else that people should be aware of?
So look, bare minimum is to really just make sure that your skin's protected, is to make sure that your eyes and hands, at least, and ideally wearing long sleeves. With any gloves that you wear, they need to be chemical resistant, so either nitrile or PVC. The only other suggestion I'd make for PPE would be, if you're in an open area, is to just make sure the area is ventilated. If you're in an enclosed area, is to make sure there's some proper ventilation to actually keep the airflow through, because you don't want, when the epoxies are unmixed and curing, then they do give off, some of them can give off a bit of an odor. So it's to make sure that fresh air is being pushed through.
Great. Just one or two more questions, Mark, and I think we'll start wrapping up. But in terms of the repaired pump with your product, does that still demonstrate the same or better efficiency as a new pump?
So look, we've got a bit of data on that one as well. On the smaller pumps, it's not as noticeable, but on larger pumps where you have got some significant wear, or there's a lot of pitting, corrosion on the surface of the pump, then you'll start to see a decline in efficiency. Because this rebuilds the surface back to a smooth, low friction surface, in a lot of cases actually on larger pumps, that we've actually seen the efficiency increase above what it was when it was new, and it's also reduced power consumption.
Yeah, right. Okay. And then last question for you, in terms of the life cycle and the length of that life cycle, once you apply your products to any of these components, what's the expected life cycle once that's done?
So expected life cycle generally will be at least as long as the pump ran when it was new, but in some cases, again, that can be extended further than what the original component will be, depending on what the pump itself is made out of.
Yeah, right. So I'm just seeing a lot of cost savings and efficiencies here. So well done.
Exactly.
I think everyone will agree that that's certainly allowing people to be more efficient and extending the life of that bit of equipment. Actually, Jag's just got one last question. I think we'll wrap up. And he says, "Is there a limitation on the amount of wear you can repair?" Good question, actually.
That's a very good question. Yes, there would be a limitation, and that is really that point is really when the integrity of either of the components, the original structural integrity, is beyond. I suppose when we determine it to be beyond salvageable. So, in saying that, look, in some cases, we have repaired pumps where there's holes right through casings, or there's pieces of an impeller worn right away, but there's a couple of tips and tricks on how we would normally do that. So we'd look at those on a case-by-case basis.
Fantastic. Well, thanks for that, Mark. That's great. Look, I think everyone's really appreciated the session today. And for any of those interested, we will obviously be posting today's webinar across our websites and various channels. So if you wanted to share it with anyone, this will be available early next week to share, and we'll alert you when that happens. Also, if anyone wanted to get in touch with LOCTITE or with Henkel adhesives, there's an email address, loctite.inquiries@henkel.com, or the website henkel-adhesives.com/au. Mark, thank you so much for today. It was great to have that experience and actually see the product being applied in action. So thanks for that, and thank you for everyone attending. This is the end of today's session.
Thank you.